So in this STC, we'll be taking care of different labs. So in this first session, so I will be first introducing about the software. So what are the features of the software, how to start using this software, and then I will explain about how to perform experiments related to digital electronics. So basically the tool which I am going to explain in this session is called Multisim Live online simulator. So we can conduct digital lab experiments, electronics, basic electronics lab experiments, applied electronics lab experiments, op-amp lab experiments using this particular tool. So out of the 10 sessions, 4 sessions are devoted to this particular tool only. So I will be first explaining how to join this tool, how to start using this tool, then we'll go for that particular digital lab experiments. So let me share my screen. I hope my screen is visible.
Yes, sir. Yes, sir.
Yes, sir.
Thank you, thank you. So dear participants, to start using Multisim Live Simulator, so we need to first go to say Google, then we need to type Multisim Live. So when we click on this, so we get this link of Multisim Live Online Circuit Simulator. So or basically we need to go to multisim.com. So this particular Multisim Live online simulator is a cloud-based simulator where no download is required. What we need is we need to create just one account, and this then we can start using this particular tool. So there is no download required. This is totally online simulator. If after creating one account using simple steps, we can start using this particular tool. And this tool is basically by the National Instruments, so NI. So NI is providing this Multisim Live tool. So this tool is free, and there is one premium version also. So what we are using is the free version. So in free version we have certain restrictions. Premium version is the full version, but with this free version only we can conduct many of our experiments which we need to conduct in our labs according to the syllabus. So this free version is sufficient for starting practice, and especially in such times when students are not in our lab, so they can perform at their own places. So for creating the account, so we need to go to sign up as in any other we can say the software. So we need to create this by filling these particular entries. So we have to enter our name and our say, short name. Then we have to decide about role, within company, email address, password. So just by clicking on this create account, so we by filling these boxes and then clicking on create account, we can create the account and we can start using. As I have already opened up one account in this, so I will not again open this account. I will directly go to the login. So once we have the account, then we can log in. So for login, we need to use that email and password which we have entered while signing up. So I will be just entering my email ID, and then I will enter my password. So after entering username, password, so this is the landing page. This is the interface at which we first land. So here we can see that there are certain options. So let us first explore these different options. So here, first thing is that we have this link particular tab feature. So if we click on this, so it will give us a feel about the capabilities of this particular tool. So first point here is expanding the multisim experience. So most of us might be knowing that multisim is a very popular software which we use in our labs for different applications for designing circuits and simulation of different circuits. So Multisim Live is that the online version of that Multisim which we use traditionally in our labs. So this particular Multisim Live tool is a new feature, and it allows user to take same simulation technology to anywhere, anytime, or on any device. So we can use this Multisim Live anywhere, anytime, any device, provided we have access to internet. And then another feature of this is that it is not also dependent on any particular operating system. It is not there that it is work only on Windows or Mac or Linux. So it will work on all. So what is required is we need a standard web browser and a good internet. So these are the two only requirements to start using this particular Multisim Live tool. And in this particular software, another feature is that there is no installation required, so we can start using the circuit simulator directly from the net. So as we have opened our one account, so then what we are getting is the standard interface which we will be using for conducting different experiments or for performing different experiments. And then another thing is that same industry standard SPICE simulation. So this particular tool is of industry standard. So it is not there that if we are using free online version or cloud online version, so it is having any restriction on any particular basically the standard of the simulation. Although there are restrictions on certain components, so in free version we are not having all the components which are there in premium version, but the components which are available, using those components when we perform simulation, it is of industry level or at par with premium level. Then we can share circuits. We can design circuits, and then we can share our circuits with our groups. So there are options of groups. I will be just showing that we can create public circuits, private circuits, and then we can share our circuits with public groups or private groups. So that is option given by this particular tool. So we can also share our circuits, and in similarly we can also get circuits created by others. So we can explore circuit created by others. So we can go to the public circuits, and then we can find circuits. So there are around 1 lakh circuits which have been uploaded on public circuit spaces. So we can go through those circuits. We can use those circuits. Then even we can save those circuits in our account. So that is possible. So using this circuit simulator, so we can say that this completes the circuit teaching solution. So if we are using this particular tool, so we can easily teach our students about the circuits or the circuit simulation. So then there are certain other features, like new features are added all the times, and when we are using this online version, so this is always up to date. So we can what we are using is the latest version of the tool always, because we are using cloud version. And then there is this possibility also, although we will not be exploring this particular feature. There is another tool from NI which is called Measurement Live. So there is compatibility of Multisim Live to Measurements Live. So although this will not be the focus area of this STC. So these are some of the features. Then we can skip on this pricing part, as we have to use only the free available version. Then we can have circuits of different types. Like here we can see under circuits there are two different categories: my circuits, my favorites, my groups. So my circuits are those circuits which we design and save in our particular login account. So those are available under my circuits, and then we can mark circuits, certain circuits as favorites. So those circuits will be available under my favorite tab. Similarly, we can join different groups, or we can make this groups over this particular tool. So those groups will be available under my groups. Then, so these are three tabs related to our own creations and our own likings. Then there are certain these options which are public circuits or which are available to all. So there are certain circuits which are called public circuits, then reference circuits, and there are also certain groups which we can join. So let us explore one of this. So when we see on public circuits, so we can see that there are different categories of circuits. So here we can see under public circuits. So these are the popular tags. So we can get circuits related to supply, AC circuits, amplifier, DAC, ADC, VJT. So these are all different tags, and we can have circuits related to these. Even if we are not sure about the circuit, and we can search from here, like here, say we search about the circuit of counter. Then the other users who have uploaded their circuits as public circuits. So under this, when we search that particular circuit, so related circuits will be available. So here we can see when we have searched with this keyword counter. So what we are getting is 4-bit digital counter. Then there is another related circuit, so counter to 7-segment display. So this way 3-bit counter. So we can click on any of these circuits, and we can start exploring the circuits designed by other users also. So if we take all the circuits into account, so let me again go to public circuits. So now we are getting all the circuits. So if we see all the circuits, so then here we can see that there are around 1 lakh pages of circuits. So on each page we can see that there are around 15 to 20 circuits. So that is the way we can explore the circuits using this particular online platform. So we can get many innovative circuits and circuits implemented using different methods or different forms of the circuits which we develop. Then let us go to this next tab, resources tab. So under the resources tab, the most important thing is this help. So when we click on this help, so we are getting this page. So here we can see that we have tutorials related to creating designs, simulating our designs. So then again, interfacing with measurements live. Then there are detailed descriptions about drawing schematic. There are details about simulations. And then again, there are details about components. So we can explore these different, basically, different resources given here, and we can advance our knowledge using these various tools. So today, in this first session, we will be creating our design and simulating our design using different components. So I will be just going through one particular cycle of how to create the circuit, how to simulate circuit, how to see the waveforms. So now when we want to create any circuit, so first thing is that we need to click on this create circuit. So as I click on this create circuit, now this particular interface will open. So here you can see that this is the schematic area. So this button here, the highlighted tab is the schematic. So here we'll draw our circuit. And to draw the circuit, so if we have to perform experiments in our say laboratories in actual physically, then to draw the circuits or to perform experiments, what we need, so we need different components. We need different circuit components, and then we also need certain power supplies, and we also need certain types of multimeters or voltmeters, or we can say the measuring instruments. So in this online version also, if we have to draw the circuits, if we have to perform the experiments, so we need all those components, power supplies, as well as measuring instruments in this particular sort form. So this side tab, so this basically contains all those components and different instruments. So let us explore these tabs one by one. So when we click on this particular tab, so here we can see that it is written as analysis and annotation. So what we can have from this particular tab is that we can have a voltmeter, we can have a ammeter to measure current, so or we can have a combined voltage current measuring device. Then there is a voltage reference. So when we have to measure voltage, so we have to connect two and one to positive, another to negative. So this reference acts as the negative terminal. So we'll be just using this reference. Then there is text annotation. We can have annotation of the circuit using this particular tool. Then if we have to measure digital, so in digital we know that we measure either 0 or 1. So we can use this scope, which is for measuring the digital waveforms. So these are some of the measuring instruments which are available. Then next option is schematic connectors. So we have these different options. We can use ground, then we have this connector, we have this junction. So if we need to use any of these three connectors, then we can select from this particular tab. Then next we have these sources. So here we can see that there are all different types of common sources available when which we need to perform different experiments. So here we can see that we are having AC voltage, AC current, clock voltage, clock current, then triangular voltage, triangular current, so DC voltage, DC current, step voltage, step current. So all different types of sources which we commonly use in our experiments. So those are available. We can just select one of the required source, and then we can start using that particular source. Then next we have this particular tab which is named as passive. So it contains the passive components. So under this passive components we have resistor, we have capacitor, we have inductor, we have potentiometer, we have fuse, we have transformer, we have coupled inductor. So under this we have certain other types of resistors like voltage controlled resistor, impedance block. So all these different components are available under this passive block, and we can if we want to use, then we need to select from this particular tab. Then there are options under this analog tab for the mainly op-amp. So here we can see that 3-terminal op-amp, 5-terminal op-amp, ideal comparator, 555 timer, then certain op-amps like LM324A, UA741. So basically what we are having is, so when we click on this, so here what we are having is general purpose operational amplifier. So this is a 5-terminal general purpose operational amplifier. And but if we want to use a particular component, we want to use a particular component number, then in this free version there are certain options already available, like 555 timer is available even under op-amp. So if we want to specifically use this LM324A or UA741, so then we can select from there and we can start using these specific components. So certain components are available by their number. So when we select those components by selecting their number, so what we are using is actual soft version of that particular hard component. Otherwise what we are using is we are using a general purpose or the general type of particular component. Then next is diode. So under diode we have this PN diode, Zener diode, light emitting diode. So these three different types of diodes are there. Then there are certain other diodes by specific numbers like this IN4148. If we want to specifically use this diode, then we can select this. So these are the options available under this particular diodes tab. Then we have many options related to transistors, NPN, NPN 4-terminal, PNP, PNP 4-terminal. So these different options, NMOS, CMOS, JFET. So these different types of options are available under transistors. So if we want to design transistors based circuit, so as we will be doing in our applied electronics lab, so we will be using these transistors and we will be implementing certain experiments. So under then again these different options, we have the specific component numbers. So if we want to use these component numbers, then we can also select these component numbers. As this is a free version, so we'll not be able to find much basically options to select the specific component numbers. So we have to use most of the time general models of these different components. But these general models are good enough to perform basic experiments which we perform in our labs. Then next we have this indicators. So under indicators we have again lamps and LED, 8 LED bar, buzzer. So these different types of options are there under this indicator tab. So we can start using in our circuits as per our need. Then we have these switches. So if we want to use any of these switches, then we can select these switches and we can implement our circuits using these switches also. Then this particular tab is for modeling blocks. So under this modeling blocks, we have voltage controlled voltage source, voltage controlled current source. So similarly, other dependent basically sources. So if we want to use dependent sources, then we can go to this modeling block and we can start using. And this tab is the electromechanical tab. So under this, we have different types of relays. So here we can see normally open relay, normally closed relay, combination relay. Then there are certain machines like DC machine, permanent magnet, DC machine, wound field. So these options are there under this particular category of electromechanical. And this is the option for basically this related to power. So here what we are having is the linear regulator. So if we want to use any regulated power supply, then we can select this linear regulator blocks and we can start building our regulated power supplies. And this last tab is related to the digital, so which will be mainly I will be explaining in this particular session. So under this digital, we have different options. So this is the digital constant. So digital constant means, as we know that in digital we have to apply either 0 or 1. So using this particular digital constant, we can apply a 0 or 1. Then we have options of AND gate, OR gate, NAND, NOR, XOR, XNOR, buffer, and inverter. So these are the options which are available in this particular online simulator free version. So we have basically all the basic gates. So if we have to implement the circuits, then we have to design using this basic gates. So under this AND gate, we have further options like 2 input AND gate, 3 input, 4 input, 5, 6, 7, 8, up to 8 input. We can have AND gate. Similarly, there are options for gates, different input numbers. So for OR gate also we have from 2 to 8 input. And similarly for other gates, we have different number of input pins. Like this NAND, we have again 2 to 8. So these different number of pins are there at the gates, but we are not having other advanced blocks. Like we are not having, say, JK flip-flops, or we are not having any, say, multiplexer, demultiplexer blocks. So if we have to, say, implement multiplexer or demultiplexer or adder or any flip-flop counter, using this, what is the option available is that we have to implement all those circuits using the gates. So we can implement multiplexer or other circuits using gates, and then we can start exploring those circuits and we can see the working of those different circuits. So we are having basically only these gates available to design digital lab experiments. So before I actually start with digital lab experiments, so let me give some, say, feel of the tool. So how this tool acts, how to use different basically options. So let us first we create a voltage divider circuit. So if we want to design a voltage divider circuit, so what we need to use is we need to use 2 resistors and one particular voltage supply. So I want to use resistor, then what I need to do is, so I need to go to this particular passive block, then I will click on resistor, and this way I can place this resistor on this schematic at any place. When we click on this, so here we can see that by default there is some value like 1 k ohm. Say if I want to change this value, so I will click on this particular value, then I can drag and I can change this value, or I can directly click on this value and then I can like change the value. Say I make this as 2k. So now I have basically installed one resistor. So I have placed one resistor. So say I want to use have another resistor, then one option is that I can copy component from here. So here we can see that this is for copy, this is for changing the direction. So we can change the direction. So this is for deleting. So similarly, this is for flipping or mirroring in this particular component. So these options are there. Or again, I can also basically drag from this the menu of the tools. So now here I am say placing second resistor. So say I am keeping its value as 1k ohm only. So all by default there are names R1 and R2. So even we can change these names of these resistors also. So now another thing what we need is we need a basically power supply. So let us we say we want to use this DC voltage. So I will click on the DC voltage and I will place at the desired location. So by default, you can see its name is as V1 and its value is 5 volts. So again, I can change the value of the voltage. So whatever the value I want to make, so I can make that value. Say let us, I want to make this as 10 volts. So I'm using 10 volt supply. So now what I need to do is I need to interconnect these different components. So for interconnecting, so we need wires in physical mode. So similar to that, we need connecting wires here in virtual mode also. So when we want to interconnect, so we need to click on this particular tip of any component. So when we click on this, so we'll have this type of symbol. Like here you can see symbol is drum type symbol is there. So we have to trace our wires by placing our mouse button. So I am just connecting using the mouse. So when we are at the connecting end of other components, so this wire will show connection. So just by clicking using the mouse, we can make this connection. Similarly, to connect these two, so we can again click on that particular end of the component, and then we need to drag that particular symbol, that connecting wire, to the other components connecting end. So here you can see when connection is possible, so we'll have this type of pop-up. So just I need to click on this particular point, and then we'll have the second connection. So here the connections has also been numbered as 1, 2, like that. So now I have to connect this end to the other side. Say I want to make this circuit like this. So now circuit is complete. So here while tracing we can have certain bands, but these bands will not affect, or we can also change these bands and we can make these lines straight just by dragging. So this is also possible. So now we can see that circuit is complete, but one special component is missing here, that is ground. So ground is very essential component in almost all different circuits. So we need to connect this ground terminal, then only the circuit will work properly. So now our circuit is complete, but if we have to measure voltages, then we need voltage voltmeters across these resistors. And if we want to measure current in this particular circuit, then we need ammeters. So we need to basically connect voltmeters and ammeters also. So to connect the voltmeter, so we need to go to this particular analysis and annotation tab. So we have to connect on, we have to click on this voltage. So when we click on this voltage, so a voltmeter will be selected and we can connect this voltmeter at the desired point. So now this is one end of the voltmeter. So if we do not connect the second end, so by default, it will measure the voltage from this point with respect to ground. So this will measure the voltage between this point and ground. So that reading will be shown here. But if we want to measure across particular say length, say we want to measure across this particular resistor, then what we need to connect is we need to connect the voltage reference. So we need to go to this particular voltage reference and we need to connect that reference. Now, so we have connected voltmeter and volt reference. So we need to assign this reference to this particular voltmeter. So here you can see that it is named as PR1 and it is named as reference 1. So we need to assign this reference 1 to this PR1. So for that, so we need to click on this voltmeter. So when we click on any component, details of that particular component will be shown in this sidebar. So this sidebar will show different options related to that component. So here we need to select this particular voltage reference. So we need to go to this reference 1, as we want to assign this reference 1 to this particular voltmeter. So when we select this reference 1, now this voltmeter, this here you can see that it is ID PR1. So what we are changing is for this particular component PR1. So for this PR1, now the voltage reference will be reference 1. So it will measure voltages across this particular resistor between these 2 points. Similarly, we need to connect voltmeter across this resistor also. So using same procedure. So we'll first select voltmeter from this point, and then we'll connect here. So it is by default named as PR2. So now we have to assign reference for this. So voltmeter and its reference. So it is now, you can see by default it is named as reference 2. So we need to assign this reference to this PR2. So we'll click on this PR2. We'll go to this voltage reference, and then we'll select on reference 2. So now this reference 2 has been assigned to this. So now using these voltmeters, voltage probes, we can measure the voltage, but to measure the current, we need to connect the ammeter. So we'll select this ammeter or current scope, and we'll connect that current scope anywhere in the circuit. As we know that in a series circuit, current is same at all points. So we can connect this ammeter at any point. So for ammeter, there is no need to have voltage reference, because it will measure the current in that particular, basically current flowing through that particular circuit path. So it will measure that current. So there is no need to have voltage or a reference for current. So references are required for these voltage scopes only. So if we forget to use references for voltage scopes, then automatically it will measure between that point and ground. So that is the way the circuit works. So now our circuit is complete. So what we now we need to do is, so after completing the circuit, so we need to run this circuit. For that, we need to basically run this simulation. So we'll click on this play button. So this is basically run simulation button. So when we click on this, so we can see that there are different values. So this simulation is running. So here we can see that different simulation time is going up. And here we can see that applied voltage was 10 volt. Now this voltage drop across this resistance is 6.66, and across this is 3.33. As we can check using the simple formula of voltage divider, that this is resistance is double than this 1k ohm. So the voltage drop will be double than this particular resistor, and the current flowing through this particular circuit is 3.333 milliampere. So this is how we can run this circuit. So this is the way we can easily design our circuit, and we can run our circuit. And the next point required in our circuits is that we need to see waveforms. As we have connected these voltmeters, so we might be interested in seeing the waveform. So here we can see the voltage value is 6.6. Here it is 3.3, and current value is 3.3 milliampere. So to see the voltages, we need to click on this grapher. So when we click on this grapher, so it shows the different waveforms of the signals which we have selected from the circuit. In the circuit, we have selected we have connected 3 probes, PR1, PR2, PR3. So when we click on this, so we can see that we are having 3 probes, PR1, PR2, PR3. So we are having 3 waveforms, and these waveforms are shown using different, we can see the different line colors or line styles. Here we can see that this voltage is the first voltage drop across resistors around 6.6. Then this is current, and this is the second voltage. So on this side, voltage values are given. On this side, current values are given. So this way we can see the voltages also. If we want to see circuit and this waveform side by side, then we can click on this subplate. So when we click on this subplate, so we'll have this circuit. So we can zoom in, zoom out our circuit, and we can drag and drop. So, and at the same time, we can also see the waveforms. And if we want to see the change. So then say we want to see the change, we can change this resistance. Say we decrease this value. So then voltage drop will across this resistor will decrease, and the decrease in the drop will be dropped across second resistor. So here we can see now 6.2, 3.77. So these values are again changed. So waveforms has been changed. So this is how we can see the schematic, waveforms, or both. At any time we can end this simulation, and then there are options. So after making the circuit, after running the circuit, after analyzing the circuit, so what we need to do is we ask our students to draw these circuits in their practical files, and basically write different results, draw waveforms. So all those things can also be done using this particular tool. So we can go to this particular tab. So we can save our circuit, we can export our circuit. So these different options are there under export. So we can export schematic image, like we can export the image of the circuit. We can export the grapher image, means we can export the image of our waveforms which we are getting on the grapher, or we can also export the CSV file of the waveforms data. So we can export this Excel sheet, and then we can perform certain experiments. Like in most of the labs, we first measure certain values. Like say we want to measure, we are say performing the rectifier circuit. So then from the rectifier circuit, what we measure, so we measure the peak value or the different variables related to the rectified output. Then we calculate the efficiency or the ripple factor of the rectifier. So while calculating efficiency or the ripple factor of the rectifier, so we use certain measurement values, and then we perform calculations. Similarly, we want to perform using this particular tool, so we need those values. So instead of noting down the values on paper and pen, so what we can do is we can export this graphical data, waveform data, and then we can use that Excel sheet to perform different types of calculations which are required for that particular experiment. So this CSV file is very helpful in performing different analysis related to the readings which we take from our circuits. And even under when we want to save, so there are different options of saving the circuits. So private, public. So as we are using the free tool, so we will not be having the option of saving the circuit as private circuit. So this option is locked. So using the free tool, we can save our circuit only in the public circuits domain. So we can name our circuit, we can write a description to our circuit, we can add a tag. So when we click on OK, so that circuit will be saved under the public circuits, as well as if this circuit will be available under my circuits option when we land in our this particular login portal. So this is how we can start using this tool using this simple voltage divider circuit. So we can have the first feel of this particular tool. So I will not go into details related to the other analog circuits, because rectifier circuit, transistor circuits, or op-amp circuits. So these will be taken care by Mr. Balwinder in his lectures. So directly now I am moving towards the digital lab. To perform digital lab, so what we need to do is, so we need to go to this digital tab. So let me discard these changes which just I have made. So what I will do, so I will go to again my circuits. So I will not save any changes. So I will not save this circuit. I will discard that circuit. So if say earlier, like I have saved this circuit of half wave rectifier. So if I save any circuit, so it will be available under this my circuit. So this way we can have that link for that saved circuit, and we can click and we can again open and start using that circuit. So any basically question or clarification required at this point? So before I move towards the digital lab experiments. So any of the doubt or the clarification required at this point, so I'm open to that. Otherwise, we'll be moving to next particular.
Excuse me, sir.
Yes, ma'am. Yes.
Yes, sir. So just wanted to know how we got both the things, I mean schematic, simultaneously on the same port grapho. I'm not getting that, sir.
Okay, ma'am. Let me just go to that particular create circuits tab. So when we click on create circuits, so we go to this particular window. So under here only we created that circuit. So when we click on this schematic, so what we'll be seeing only the circuit part. When we click on this grapher, what we'll be seeing only the waveforms, and those waveforms for which we have connected scopes on the circuit when we create the circuit under this area. So if we want to see both side by side, then we need to click on this split. So when we click on this split, so we'll have schematic on this side and we'll have waveforms on this side.
Right, so sir. Thank you. Thank you, sir.
Hello, sir. Good morning. I want to ask one question. Could you please define the role of voltage marker and the voltage reference marker that you have discussed in this circuit? I want to know what is the difference, why we are introducing the both, and what will be we will get the result after getting this.
Right, ma'am, right. So, ma'am, when we actually practically in physical lab, so when we have to measure voltage, so how we measure voltage? So we use two terminals, right? So we connect those two terminals across that particular component across which we want to measure the voltage. So same is true for this particular online circuit also. So let me again say connect that that circuit. Let me complete that circuit.
Because generally in the PSpice software, we will introduce only one voltage marker. So that's why I'm talking about, I don't know about the reason behind that.
Yes, ma'am, let me complete this.
Okay, sir.
So this was the circuit, and here we had this ground. So when we click any voltage probe, say we connect voltage probe across this point, right? So by default, so this particular tool will measure voltage between this point where we connected the probe and ground. So if we do not connect that voltage reference, so this reading which will be shown here, that will be of the voltage between this point and the ground. So if we are interested in reading voltage across this component only, so then we need to connect the second terminal here. So as we basically connect in our physical lab, right? So to to basically mark here that we want to connect the voltage across this resistor or between these 2 points, then we need to have this voltage reference. So we'll wherever we'll connect this voltage reference, so we'll after connecting voltage reference, so we also need to select this voltage reference from this settings section. Then only, so this particular voltage scope will show the reading between this point and reference one. So this is the reason basically why we connect this voltage reference.
Sir, this is the potential difference.
This is basically the drop across this particular component. So if we even change the direction, so it will basically we'll have the change in sign. So what is the voltage drop or across this particular resistor? So that will be shown here at this particular point.
Okay, sir. Okay. Thank you so much.
If there are no further clarifications required related to this particular circuit, so let us move towards our main topic of this particular session, that is digital lab. So again, let me delete this circuit so we can delete all these components. Okay, so when we have to create digital circuits, so first thing is in digital lab, what we do, first thing is we perform basically a truth table verification of different logic gates. So that is the probably first experiments in all digital labs, whether it is at diploma level or at degree level. So we have to perform truth table verification of different logic gates. So for that we need that particular gate. So we are selecting 2 input gate. So then we need to connect 0, 1 basically digital supply to these 2 different ends. So for that, so here the option is of digital constant. So we'll go to this digital constant, and then we'll connect that particular input terminal here. And similarly for second input terminal, again that type of digital constant or the digital input pin. Right, so now we have connected the input. So in our digital electronics lab, so to check the output, we generally use the LED. So same LED we can use here. So we can we have to connect this LED to the output pin, output terminal of that particular gate. So here we have connected that particular output to the one end of LED, and the second end of this LED will be connected to the ground. Right, so this is basically the circuit or input which is required. Different connections are required to check the truth table of AND gate. So now here we can see that if we want to change this particular value from 0, 1, what we need to do is we need to click on this and it will change from 1 to 0. But that 1 to 0 change will work only if we have started simulation. So after connecting the circuit, we click on this run simulation. So here we can see that both inputs are 1, and in case of AND gate, when both inputs are 1, LED output is 1, that means LED will glow. So if we change any of the inputs, we change both to 0. So now when both are 0, 0, so output will be 0, so LED will not glow, right? So if we second input combination is 0, 1, so when we make 0, 1 in case of AND gate, again there will be output 0, so we will not be having any basically light in the LED. Similarly, if we make 1, 0, then during 1, 0 also output will be 0. But when we make 1, 1, so here we can see that this LED will glow and it shows that output is 1. So even from this, when we change from 1 to 0, so we can see that there is change in the line color. So when this line is of say black color or dark blue color, so it means the signal flowing through this line is 0. But if we change the value from 0 to 1, the color will also change. So this is also one indication of the value of signal flowing in that particular wire. So now in addition to just seeing on the LED, so we can also see this particular basically flow of signal on the scopes, on the waveforms. So for that, what we need to do is basically we need to connect the digital scope. So if we want to see the digital waveforms, then we need to connect this digital scope, so PR1. So if we want to also see the input waveforms, then we need to connect scopes according to our requirement. So at this in this circuit, say we want to see the scope, or we want to see the waveforms at these 3 different points, both the input waveforms as well as output waveforms. Now when we run this particular circuit, so when we click on grapher, so we can see that we are having all these 3 waveforms, and all these 3 waveforms are at particular now the extent of time is both inputs are 1 and output will be 1. So now if we see in this split form, so if we change any of the input, so like we have made this input 0, so this input is shown by this blue color. So PR3, so PR3 becomes 0. So accordingly, output which is shown by PR1, that is also 0 because of this AND gate operation. So again, if we make this as 1, so both are 1, 1, so that effect will be visible here. Right, so this is how we can check the working of AND gate using this particular simulator, and then we can save our circuit, we can export our circuit, and then we can have the images of the waveform or the circuit as per our need. Similarly, now say we want to check the OR gate, then we can delete that AND gate from there, and we can select that OR gate. We can select 2 input, 3 input, or any desired number of inputs gate. Say I have kept all other points same. So now I have, instead of AND gate, I have used OR gate. So again, let me connect this particular OR gate. So 2 inputs, then outputs. So again, I need to connect these probes, PR1, PR2, and third probe here. So now again, we can see it's working. So when both inputs are 1, 1, so output is 1. So for OR gate, so when inputs are 0, 0, output is 0. When inputs are 0, 1, we know output is 1. Similarly for input 1, 0. So again, we have output 1 in case of OR gate, and when we have both inputs as 1, 1, so we'll have output 1. So this way we can verify truth table of 2 input OR gate, or we can connect 3 input OR gate, and or any basically the desired number of inputs for the OR gate. Up to 8 inputs we are having the possibility here. So again, if we want to see the waveforms, we can click on split to see side by side, and we can see the effect on the output when we change these inputs from 0, 1 or 1, 0. Because in OR gate, output will be 1 if any of the input is 1. So accordingly, there will be change in the output. So this is how we can verify different gates using this particular tool. Now say we want to go for other circuits. Say we want to implement our other circuits, say we want to implement universal gates, so we can directly have NAND NOR gates, or we can generally what we do in second experiment in our most of the digital labs is to implement the universal gates. So basically to implement NAND or NOR using to implement AND or NOT gates using only NAND and NOR. So instead of this using NAND gate for implementing only other gates like AND or NOT, so we can do that also. So we can select the required number of components, and then we can interconnect. Like say we want to have different numbers of AND gates, NAND gates, and we can have accordingly we can form the connections, and we can implement the desired gate using that this particular NAND gate only, basically universal gate implementation. So instead of going for this universal implementation, so let me go to the implementation of half adder. Say we want to implement half adder, then we know for half adder what we need. So we need one XOR gate and one AND gate. So 2 input AND gate and 2 input XOR gate is required to implement or half adder circuit. So when we implement half adder circuit, so what we do, so we have 2 inputs. So let me show those 2 inputs by these 2 digital constant blocks. So these 2 inputs are applied to both XOR as well as to AND gate input. So this particular input to this gate, and then this second connection. So this input is applied to both inputs of XOR as well as input of AND gate. So now this input to second, this is second input. So here we can see, although these are overlapping, but there is no connection. So when there is any connection, so we have this type of, we can say the node shown here. So this shows the connection. So now we know that this our half adder circuit has two outputs. So one output is denoted by the basically sum. Output of XOR gate is sum, and output of AND gate is carry. So to check two outputs, so we need two LEDs. We'll have first LED here. So we'll connect output of this to this LED. And similarly, to see the output of the second gate or the carry output, so we'll have second LED connect here. So now we need to connect ground to other pins of other side of LEDs. So now we can even change this name. So like instead of LED, we can write sum. So this output is basically carry. And here DG1, DG2, we can write A. Generally we write A and B. So now we'll be running this circuit and we'll be verifying the truth table of this particular half adder circuit. Okay, so here you can see that although circuit is working, so if we want to see waveforms, the message was there that there are no probe connected. So if we now click on this grapher, so we'll not see any of the waveforms. The circuit is running. We can check these truth tables or the working of the circuit using the LEDs, but we'll not be able to see the waveforms because we have not connected any scope at any point. So let us first verify the circuit using different combinations. So when we have both inputs 0, 0, our inputs are 0, 0. So then output will be both sum and carry output will be 0. So truth table of our half adder is when both the inputs are 0, the output, both outputs will be 0. So now we can see that both the LEDs are in off state. So now if we change the input to second combination, and second combination is 0, 1. So when 0 and 1, so we check the truth table of half adder, and in that case sum output is 1, carry output is 0. So here we can see that some LED is glowing, carry LED is not glowing. Now if you go to the third input combination, that is 1, 0. So here we can see for 1, 0 again, sum output is 1, carry output is 0. So now if we go for 1, 1 input, so in case of 1, 1 input, we know sum is 0 and carry is 1. So here sum, this particular sum LED is in off state, carry LED is in on state. So that way we can observe the working of this half adder circuit using this particular circuit connections. So now if you want to see the waveforms related to these different signals, so then we can connect different voltage probes. So we need to go to this analysis and annotation tab. So we need to click this on digital scope, and we need to connect these different digital scopes. So we can copy paste also. So instead of selecting again and again from this tab, so we can, what we can do, so we can duplicate or we can copy from this, and we can connect like this. This is first input, this is second input, right? Even we can shift this to this point, or this to this point before the basically terminal. So here again we can change the these output names. So instead of PR1, we can connect this as sum. This we can write as carry or C. Again, this we can write as A. This we can write as B. Now, when we run simulation, so here we can say that it is message is high, low, high according to the signal strength. So that message will be there, and accordingly there will be waveform in the graphics section. Or if we click on split, so then we can see. So we'll again start from the first row of truth table. So when input is 0, 0, so we can see that A and B. So A and B are shown by these two colors, blue and this particular same magenta color. So A and B are 0, 0. Both outputs are 0. So this particular color is for C and this is for S. So again, you can note. So if we hover our mouse, so if we hover our mouse on the waveform, so it will show its all details. So it is, but at that point, so output is named as S. So what we are seeing it is we are seeing at 4.815 seconds, and its value is 0. So X is value, Y axis value, so both are shown. So now if I change to second input combination truth table 0, 1, so we'll see that this input is going to 1, and also some output is going as 1, which is required as per truth table. Now when we make 1, 0, again some output will be 1. Now that particular input will be shown as 1, and second will be shown as 0. So when we click on 1, 1 here, so both inputs are 1, 1. So we can see both inputs are 1, 1. So some output is 0 and the carry output is 1. So this is how we can even see the waveforms by connecting different probes in the schematic circuit diagram. Right. So this is how we can perform this digital lab experiment of half adder. So now I want to connect the full, I want to design the full adder. So what I need to do is, so I need to have the required number of components. So as there is no full adder IC available or the full adder block available in this particular free simulator. So if I want to implement the full adder, that also will be implemented using the connection of different basically components from this particular available components only. So let me delete these components so that we go for the connections of full adder. So in full adder, we know that we have 3 inputs, so we can mark this as the third input. And in full adder, now there are 2 options to implement full adder. One option is to implement full adder using only basic gates, that is AND or NOT. And second option of implementing full adder is using 2 half adders. So we can use 2 half adders and we can then implement that full adder. So this already 1 half adder is there. So we know that in full adder circuit, so even if we are not able to recall say full adder circuit, so as we are using this particular tool online, and we can even search our circuit and truth table. Sometimes students are not able to recall the circuit. So what we can go to Google and we can search that desired circuit, and then we can implement circuit according to that connection. So we can go to any of the link which is having that particular circuit. Say I am going to this. So here we can see the different full adder circuits are there using half adder, and we can have we can take references from this, and similarly truth tables are available, so we can have the references. So let me implement this full adder circuit. So again, what I need is components for second half adder, so output of this particular XOR gate is applied as one input of second XOR gate, and the second input of that is this third input. In half adder, we know there are 3 inputs. So again, we can refer to this particular. So here, output of this particular XOR gate is connected as one of the inputs to second XOR gate, and the second input of that XOR gate is the third input of half adder, which is we denote by C in. Okay. Now there will be another AND gate, so these both inputs will be connected as inputs of that AND gate also. So we'll be doing same way. So we'll connect one input of AND gate to this output of XOR, first XOR and second. Right? Another circuit connection required is now the outputs of both these AND gates. So those will be connected with inputs of XOR gate, inputs of OR gate, and that output of OR gate will be the output carry. So we'll do the same way. So we have one input, output of AND gate at this point, then second output of AND gate at this point. So we need one more OR gate. So say we want to place at this point, right? So one input of this OR gate is output of this AND gate, second input of this OR gate is the output of this AND gate. Now this output of this will be the carry out. So now to see the outputs, again we need the LEDs. So we'll connect the LEDs at both the terminals. So this LED and then ground of this LED, right? Similarly, second LED. And again, ground of this LED. So now you can see that this circuit is completed. So all the connections we have made, but we have not connected probes at the output. So let us connect those digital probes also. So this probe is for sum, and this probe is for carry, and similarly this third probe is for third input. Okay. So while placing the probes, we need to, before releasing the probe, we need to check proper connection. So there should be proper connection. So like we can name this as C in. So this will be sum. So this will be C out. This way we have now connected all the probes. So let us run this particular full adder circuit also. So when we run this circuit, so now here we can see that all inputs are 1, 1. So both the outputs are 1. So if we make all inputs 0, 0, 0, both outputs will be 0. So according to truth table, so we can go to this truth tables. If we go to second input 0, 0, 1, so sum should be 1, carry should be 0. So 0, 0, 1. So sum is 1, carry is 0. Then third row 0, 1, 0, again 1, 0. So let us go to this row 1, 0, 0. So when we have the first input as 1, these two as 0, 0, the sum output will be 1, carry 0. But in this case, when two inputs are 1, 0, 1, 1, so sum will be 0, carry will be 1. Let us go to all these combinations. So for first, let us make 0, 1, 1. So now when we make 0, 1, 1, so carry is 1, sum is 0. And when we make 1, 0, 0, so sum will be again 1, carry will be 0. So similarly, we can apply all different combinations of truth table and we can see the outputs accordingly. So when all the inputs are 1, both the outputs are 1, so that we can see. And similarly, as I have shown earlier, so we can also see all these different basically signals on the this graphical window also. So we can change different signals, and accordingly we can have a view of different waveforms, and those changes will be observed in the waveforms also, right? So these are the options to implement the combinational circuits. Now the next big thing which we implement in digital labs is the sequential circuits. In the sequential circuits, the basic building block is flip-flop. So first we have flip-flops. Generally we have experiments to verify the working of flip-flops of different types, and then we go for the, say, JK flip-flop, race round condition testing, master slave flip-flop, or we go for the implementation of counters using flip-flops. So in this free version, so we have this limitation that we are not having any building block of flip-flop. So if we are going to implement flip-flops, then we need to implement those flip-flops using basic gates only, because we know that we can easily implement any of the flip-flop using say only NAND gates, or using only NOR gates. So first we need to implement those flip-flops using those NAND gates or NOR gates as per our choice. Then we can interconnect, or we can verify the working of those flip-flops, or we can further implement the shift resistors using flip-flops, or we can implement the basically counters using those flip-flops. So all those counters, shift resistors, flip-flops will be implemented using basic gates when we are using this particular free online Multisim live option. If we go for premium version, so there will be all options, but as we are focusing on the free online simulation, so we need to use these basic gates, and then we can implement any of the circuits which we want to implement. But there is one more option. So let me go to public circuits. So I'm not saving. Okay, let me save this circuit. Say I save this circuit as full adder. So I can write here the desired description: full adder circuit implemented using two half adder. So we can write our own description, add a tag. We can add tag that it is a adder circuit, or we can add any, say, combinational circuit. So that way we can add different tags. Even we can have multiple tags also. So let me save this circuit. So I am saving this circuit. So now if I, here you can notice that the name has changed to full adder. Earlier here we were having the name of untitled circuit. So after saving, that name will appear here. So now, okay, so I have already clicked on the public circuit, so it has gone to that. So here now if we go to circuits, if I go to my circuits, so then we will be able to see this circuit of full adder. So just now I have saved this circuit, so it is available under my circuits, full adder circuit. So what I wanted to show is that if we go to public circuits, here under this public circuits, we want to show to our students working of say any type of counter using flip-flops as basic blocks. So we can search the circuit of counter, or any circuit, say shift resistor, whatever circuit we want to basically demonstrate, then or we can search that circuit under the public circuit. So under this public circuits, we'll have different options. So 3-bit counter, counter with 7-segment display, T flip-flop. So all these options are there. 3-bit asynchronous up modulo 6 counter, flip-flop D counter. So we can select any of these circuits. So here we can see that so many pages of counter circuits are available. So let us first select this first circuit only. Say I have selected this 4-bit digital counter. So what we can do, so from the public circuits. We can open the circuits of other persons. We can save those circuits as our own circuits, but we will not be able to modify these circuits. So let's open this circuit. So now this circuit, you can see that this circuit is a 4-bit counter implement using JK flip-flop. So this JK flip-flop block is not there in our free version. But if we select from this public circuit, so we can import this circuit of counter from the public circuits, and now we can run this circuit. So here, if I run this circuit, so you can see, so this high, low, so or even we can go for this split. So we can see that different counter waveforms are there. So this way we can, although we will be not able to design our circuit using the free version, but we can search for these different circuits from the public circuit, and we can demonstrate our students about the interconnections. Like we can show different interconnections as per our requirements, that those all connections are there, and we can show the working of the circuit. We can show different waveforms. So here what you can notice is that one input is that same digital 10 which we have used. So if we go through this, we can see that we can change this 10, and the other input here you can see that this is clock input. So in digital circuits, most of the time we need this clock input. So if we see, let's see this first waveforms. So you can see that this is that clock inputs are different types of clock inputs are there. So we have the option here. Under this, we have the option of this clock voltage. So instead of 0, 1, if we want to apply the clock voltage or clock current square wave, we can use these options, and we can start using our clock voltage like it has been used here. Okay, right? So although we are not having JK flip-flop block here in this particular free version, but we can go to public circuits, we can search our desired circuit, and then we can demonstrate to our students about the working, about the interconnection of that circuit, which is for which the there is blocks are not available. So this is how we can search for all the experiments for our digital lab according to our syllabus, and we can easily perform digital lab experiments using this particular tool on this Multisim Live online simulator. So today I have explained about the different options related to digital lab. So in the next 3 sessions, that is first session on Tuesday and then Wednesday, Thursday. So we'll be discussing options related to the basic electronics, applied electronics, and op-amp lab. So with this, I will stop at this point. So I am open to any of the queries or doubts. So we can discuss for a few minutes before going further for break. Any clarification or query from participant sides? I am open for that.
Excuse me, sir.
Yes, ma'am. Yes.
Sir, when I go through the graph, it comes in voltage form, not in the.
Ma'am, you are not audible properly.
If I'm audible, sir.
But better. Please repeat your question.
Sir, when I draw the graph, I go for the grapher, it comes in the voltage form, not in 10.
We have seen earlier that it is coming in 10 form. So, so if we say, let's run this, I'm not sure. So how this will load. So here you can see that it is coming as 1010. So you're not getting like this?
No, sir, in the voltage form, in the AND gate.
Okay, so you might be selecting some other probe. So you have to select here digital probe. So you might have selected voltage probe or other type of probe. So if you select this digital probe, then you will have only 2 outputs, 0 and 1, as you can see that it is written here 0 and 1.
Okay, sir, I'll try. Thank you, sir.
Sir, can we copy a portion of from this circuit and paste it anywhere. Is that option available, or we have
So
to redraw every time?
what is available is that we can copy different components, so not full circuit. So as actually it is not editable. So let me go for my circuit.
Okay, sir.
So we can.
Sir, can we calculate the delay and power losses of the digital circuit in the software?
Delay in the sense.
Delay, sir. Delay of the digital circuit or power losses like other parameters.
There are different options available. So if we go to this resources, like if we go to help, so here we can see that what are the different options available related to simulation. So if we go to this simulation, so setting up simulation graphics, so there are different simulations. So you can go to this digital simulation and you can see that whether this particular option which you are saying, actually I have not used this particular delay calculation. So you can explore this particular option and you can search for this particular option which you are saying.
Okay, sir. Thank you.
Excuse me, sir.
Yes, sir.
Sir, I have joined that. I want to download this multi-sim simulator. From where I can download?
You need not to download this multi-sim simulator. Just you need to create one login. So it is a cloud-based software. So you need not to download this software. Just you need to go to this multisim.com. So you have to sign up here. So when you sign up, after that you have to basically create one account and you have to log in there. And when you log in, so you will get this type of window there.
Okay, sir. Thank you.
There is no need to download any.
Okay.
There are certain queries in Gate. Okay. Can I have recorded sessions? So all the sessions are being recorded. So we will be uploading these recorded sessions on YouTube. So after the course is over, so we'll edit these sessions and we'll upload on YouTube, and we'll be sharing the links of YouTube, basically videos of these sessions. But that will take around 1 week after this particular STC also. So yes, we'll be sharing the recorded sessions, but after this STC, after uploading on YouTube. So I think these questions we have discussed. Sir, in the free version, we have only gates. Yes, under digital tab, we have only gates. This is true. But we can go to public circuits, we can open public circuits, and then we can copy those circuits on, we can save our those circuits as under my circuits. So that is possible. Right now, just I have opened one that counter circuit using JK flip-flop. So that circuit, as we have run, we have seen the working, and after that we can save that particular circuit as under my circuit. So we'll not be able to modify that circuit, but we can save that circuit as in our circuit. So that way we can say that our students can basically complete their experiments, and they can basically complete their practical file also using different circuits. Okay, any further query? Otherwise, we'll stop for this session. Any quick query from any of the participants?
Sir, we have 2 more questions in the chat box.
Let me see.
So, excuse me, sir.
How to save circuits? I think this I have explained. Recorded sessions. Can we copy the circuit and paste? We can basically copy different components, and we can paste those components. Full circuit is, as my perception, full circuit we cannot copy paste. For reversible logic circuit design, which software is used? So for reversible logic circuit design, I think you are asking from that design point of view. So for reversible logic, basically we need to go for that VHDL. So what I have done is for reversible logic, I have used VHDL programming. So, and we have implemented certain logic circuits using this reversible concept. So I have used VHDL, or we can use Verilog. So that is the way I have implemented reversible logic circuits. Can I copy a portion of public circuit? So I think that the editing of the public circuit is not allowed. So we need to find the right circuit, and then we can copy the full circuit, and then we can analyze that circuit.
So,
Yes, there was one question. Yes.
sir, is it possible to observe all the four combination of inputs? Like we are discussing about half adder or full adder or any AND or not input, any
Yes,
input
ma'am.
combination. For
Yes, ma'am.
input simultaneously, can I see it in the screen, like in the graph
Yes.
screen, without
ma'am, yes.
altering one by one? Can we see it at a stitch, like putting a clock pulse clock for all the inputs? If the clock alters automatically, all the inputs gets altered, no? Something like that, can we see, sir?
Yes, ma'am. Yes, ma'am. That is very much possible. So there are different simulation options. So in the next session, so I will ask Mr. Dvinder to explain that also, how to basically apply all combinations. Like if you want to apply all combinations, so first you will apply 0, 0, then 0, 1, 1, 0, 1, 1. So you we can have all those variations saved on the screen. So we can get full waveform where first section will show 0, 0 and output according to that, and then 0, 1, 1, 0. So all those combinations of inputs and corresponding outputs, that it is possible. So we can easily have that. So in tomorrow's session, I will ask Mr. Dvinder to specially show how to basically show different input combinations on one screen. So that is possible.
Thank you, sir.
So now there is one question, how to give attendance. So attendance is automatic. So your name and email with which you have joined this particular live session, so that will be recorded by the Google Meet, and we'll be getting your in time, out time, and duration for which you have attended the session. So that attendance will be automatic, and we'll be marking attendance from that only. I request all the participants to join Google Classroom also. So if any of the participant is facing any difficulty in joining the Google Classroom, then we can discuss right now or maybe after the second session. So you can try joining the Google Classroom. I have already shared the link of that Google Classroom through email as well as through chat in the morning. So again, I will share this Google Classroom code in the chat. So
Hello.
now,
Hello, Balwinder Singh. Good morning.
Good morning, sir. Good morning, sir. How are you, sir?
Fine ਜੀ ਮੈਂ ਈਮੇਲ ਵੀ ਕੀਤੀ ਸੀ ਤੁਹਾਨੂੰ ਕਿ ਕਲਾਸਰੂਮ ਜੁਆਇਨ ਨਹੀਂ ਹੋ ਰਿਹਾ ਵਿਦ ਦਾ ਕੋਡ, ਕਾਈਂਡਲੀ ਉਹਦਾ ਕੋਈ ਈਮੇਲ ਇਨਵਾਈਟ ਸੈਂਡ ਕਰ ਦਿਓ ਜਾਂ ਕੋਡ ਦੁਬਾਰਾ ਸੈਂਡ ਕਰ ਦਿਓ।
ਸਰ ਤੁਸੀਂ ਕਿਹੜਾ ਯੂਜ਼ ਕਰ ਰਹੇ ਹੋ?
ਜੀਮੇਲ ਯੂਜ਼ ਕਰ ਰਹੇ ਹਾਂ।
डायरेक्ट जीमेल कर रहे हो या अपने इंस्टीट्यूट का यूज कर रहे हो?
yes my institute email.
Institute Gmail will not work actually. For joining Google Classroom, so you need to use direct Gmail ID.
Okay ji, okay.
So this problem will be faced by, I think, many of the participants. So dear participants, if you are using your institutional ID, although most of the institutional IDs use Gmail at the back end, but that ID will not work to join this particular Google Classroom. So you are requested to use direct Gmail ID, because what we have, I have created this Google Classroom in our domain name in NITTTR.chd.ac.in. Either it will accept the Gmail, direct Gmail, or only the NITTTR CHD domain IDs. So that is the problem, sir, you are facing. So although it is Gmail, so your institutional ID will not work. So kindly try using direct Gmail. So dear participants, now we'll take break. So we'll start with the second session at 11:30. So till then, so you can remain connected. This link will remain live. So we'll again become active at 11:30 with the second topic of the session. So in the meantime, I request the participants to introduce yourself over through this chat. So you can introduce yourself, your name, designation, your institute name, or if you want to share your email ID. So because due to large number of participants, it will not be possible to have introductions through a live mode, or because it will take a lot of time. So you can utilize this opportunity, this break time, to introduce yourself to other participants. And we'll start our second session at 11:30. So thank you one and all for your cooperation during this first session, and I expect the same cooperation during the upcoming sessions. Thank you one and all, and thank you Manisha for handling the technical part.
Thank you, sir.
We'll become active at 11:30.